Right. So on the schedule it said simple sacks. That was the old name. It's now simple scattering because we're adding more stuff to it. Um, and uh, just a little bit about my background. I used to actually be a scientist. My dad over there in the other room wanted me to be a doctor, right? But I kind of like computers. So if you just kind of go from top to bottom, you could see that I get more and more computery as time goes on. And I used to mainly be an X-ray crystallographer, but did little sacks. And the thing that got me programming actually even more was mainly automating workflows for gene sequencing projects, and also to get better R factors for resolution. And that was a lot of Python programming, and I used to use set and awk and shell scripts and stuff like that. Um, but then later on, I moved on to just like basically full-time software development. And the first thing that I built was for the beamline was Sachs frame slice. They gave me an 8-week contract and did that up. And then now I take care of a handful of the apps: Sachs frame slice, the mail-in site, Sachs similarity, simple scattering, which we'll be talking about. And then I'm recently trying to upgrade both Sachs frame slice and Sachs similarity, so they're a little bit quicker. And I'm just folding it into this quick little thing that I wrote where I can actually just see the curves ahead of time. And then there's also some non-web development projects that I work on, mainly that have to do with setting up APIs for simple scattering, right? So that's basically what we're going to be talking about is simple scattering, and then how they kind of also relate to mail-in Sachs and these APIs. So I guess basically simple scattering is kind of a data repository for sharing data, similar to the protein data bank for X-ray crystallography. And for Sachs, there's a couple predecessors. One was written by our group, which was called BioISIS by Rob Rambo, and then probably everyone is also familiar with the one from Dmitry Svergin's group, SASBDB. And the impetus for, I guess, Greg's original view for simple scattering was that that data is being collected a lot faster at SIBYLS than we could actually deposit it, given some of the constraints and all the details that they'd want for each data set, right? So the original goals were to just make a more simple web-based tool to, share data sets, try to take some of the better things from both of those sites, but also, again, to eliminate some of the barriers that the researchers faced and the users when they were using these other sites, and then also to add on additional features, maybe perhaps in the future once we got it running, to benefit everybody. So the real end goal, at least in the beginning, was to just make a lightweight resource, that's benefit for everybody. And just back to the note about the SEC Sachs and everything. I have some older data from the SASBDB and BioISIS. When I was making these slides, both sites were down. So this is from an older, so this is a little bit outdated from a previous talk that I gave. But, in order to, these sites are more geared towards published data. So they want to have models, stuff like that, for every file that they receive, I guess. And over at SIBYLS, I don't know if these numbers on the left here are still correct, but if we're collecting 100 images every 2 hours for HT Sachs, and I think we do 8 runs per day for SEC Sachs, and that's 600 images, right? And so Greg wanted an easier way to actually deposit these larger data sets. And so, like, when he first uploaded his first 2 data sets to simple scattering, one was high throughput from a plate, and the other one was from SEC Sachs, and he was able to do that, in a matter of minutes, as opposed to, like my experience with the protein data bank was takes about a week to do a deposit. And if you were to have to provide all the details for every single image or process data for SEC SACs, and it took a day to do it, it'd take 1.6, I calculate 1.6 years to actually upload everything, right? And so currently now over at Simple Scattering, we have over 600 SEC SACs data sets that we've uploaded, but each contains 600 files. So we're pushing a number of 400,000 files so far. And the just for time, I'm not going to really go into detail, but the application itself, it's a Ruby on Rails program or website. It uses a PostgreSQL database. Images are uploaded to, or excuse me, data is uploaded to AWS 3. This is just all back JavaScript stuff that you folks would see. And then we also deploy it on the web. So there's actually another copy that goes through Git to a cloud service called Heroku. And then it would have its own copy of Ruby on Rails, its own database, and then send stuff up to AWS S3 for storage. And then for your experience, emails are sent, and authentication is through device, which is pretty common for Ruby on Rails. So not too much detail on that. We'll just go ahead and do a quick demo here. So let's see. Let's go to the main site. I had to move. How do you get rid of this bar? It's completely in the way. Let me get rid of this. There we go. All right. So this is a site. It's at simplescattering.com. It has a I'll just go left to right. It has a dashboard that'll show you kind of like what the latest news is, some statistics, which I've been working on adding some more. Again, we can see we have about 650 SEC SACs data sets. We published 56. The ones that are considered draft, I might change that because we've made some improvements where we're actually delivering data sets that are collected at the beamline straight into Simple Scatterings to make it easier for people to publish. So that's why there's more drafts. And then you can come and see like the latest data sets here from the dashboard. If you just click on the link, it'll go straight over to the page. And then you can go ahead and you can download the data set, read about it, get all the metadata, where it's from, the sequence of the sample, all that sort of stuff, and a brief description. And when it's published, they'll be able to put their journal DOI in there, right? So that's the dashboard. And then if you just want to like go through all the open data sets, you just click on open data sets. You can sort them in different ways. It's paginated, so you can click and go to the next page or show more entries. If I wanted 25, it'll boost it up. You can basically search by author. If I type in Hora, I could get Hora. If I want to see GFP, it'll go straight to GFP. And then right now, like I'm logged in, so like I'm an admin, so I can see my data sets, right? But also I can see all the data sets, which were mostly going to be things that were collected for other people, right? And then to deposit, I'm going to go ahead and deposit on a different page here, just to show how easy it is, right? So this is Safari Grid. All right, so this is a different account that I have, and just to show how it's deposited in your account, it should automatically populate once you fill in all the stuff, who your institute that you're from, your project leader, and because I'm always switching things around to test things, I always click around different things. And in the beginning, we were going to work with HT SACs and SEC SACs in the beginning, but like I said, we've expanded that list thanks to some suggestions from different groups and people from within our lab. And so, but I'll pretend that I'm doing SEC Sax for today, and I'll just call it Bio Sax Workshop SEC Sax. And in the beginning, that's all you really need to do, that, and then add a data set. So in the beginning, you don't actually have to fill in the abstract or a description or the descriptions of what happened in the experiment or the file description. You just had to upload a data set. So I'm just going to upload a bunch of files from, let's see, where I got a whole bunch of them. Okay, right here, results.zip. So this one, I believe, probably has 100 data sets or whatever. And so I just hit that, and then there's all this other stuff I could fill out, but basically I could just say create data set. Then I'll get an email, it'll pop up, and then I can always go back to where I was, right? Oops, I don't want to log in. That was on a different browser. And then from there, you can go ahead and you can edit your information. This is for a workshop. And then I could add information about the samples. We have different sample types. Let's pretend we're doing lipid nanoparticles today. And then, well, actually, I don't know much about lipid nanoparticles, to protein, and something I worked on in the past. So I'll say rad51 and radiation DNA repair protein rad51, right? And then I could fill in the other things about the organisms, right, and whatnot. And then most important is to fill in the sequence that'll be required, right? So I'll just give it a fake sequence for now. And then still has the zip file. And I think in order for me to actually publish this, I'd have to add in some more stuff. I'm just gonna go really fast here. And I think that would be about it. And then, I can add in other files, like if I had like a related PDB file, something like that, you can add that. I'll just say it's beamline 1231. And whoops. And advanced flights source. And we'll say it was collected at 1 angstrom, and I can't remember, was it 3 meters? And then you can add some collaborators. So I'm going to say, we'll just say Greg or and Jill for lbl.gov. Hopefully, after I update that, right now I can check to see if it's actually there. So this is the one that we just made. And then now if I edit it, I can send it to the admins to see if it can be approved to be published. So I say that, are you sure? Sure. All right. So then I get another email saying that it's pending approval here. And then I am the admin, right? And so this is a different account. This is my admin account. And then I would go check out all the data sets. And it looks like this other Dave Shin has one pending. So I would come over here and we'll put Dave here and his data sets, right? So his is pending right now. All I would do is download the zip file to my downloads folder, check it, and make sure everything's kosher. And then I can turn around and edit it. And then I can say, yeah, it looks good. Let's go ahead and publish it. Yeah. So now another email sent. And then my other Dave, the one that's the user, now when he reloads his data sets, you'll see that it's published, and then it should show up here on our dashboard as the latest data set. So that's basically the super fast tutorial for the site. So I'll just go back over to a talk here. And so from that point, we started having some other goals for this, which was to up the number of data sets that were being uploaded, and also to relieve kind of like the stress of passing data to our users from our mail-in sex program. So we tethered our mail-in SACS program to simple scattering to automate basically the process that I just showed, but also to make it a lot simpler, right? And so, and then a couple other things, we allow other types of small angle scattering, so like neutron scattering, et cetera, and constantly adding more metadata to make the site more useful. And then we're also going to be tying it in, I guess, with LBNL's computation power through a new collaboration with Brave. So for users of our mail-in program, they're probably used to using, or if you haven't seen it, the mail-in SACS site. And that's basically our scheduling app where you book time slots and then have our Beamline staff collect the data from you. And then from there, Scott and mainly Scott Klassen and Daniel Rosenberg wrote kind of a program that'll take data that I export out of mail-in SACS in order for them to process your data for you, right? And then I have some API programs that'll automatically send them to simple scattering. So basically the workflow here, whoops, I guess I should have it on play, right? Sorry about that. So you as a researcher, you would request Beam data collection at the Beamline through our mail-in site. That'll generate the instructions for our staff. They go ahead and collect the data. They'll process the data somewhat, and then from there they will. We have, like I said, wrote a handful of basically API programs that like send the data up to simple scattering, and from there, once it gets up to simple scattering, the data is stored on AWS cloud storage, and then again, once you're ready to publish it, fill in that extra metadata, then you can go ahead and do what I just did on the other thing. Just click send it for approval, and then someone like me will like check it, and then we go ahead and publish it. And if you want to read more about it, there's I guess this is being recorded, so there's a paper that we published recently about it. Right. Oops. Click the wrong button. Page. Oh, we better go on over to demo. So like I said, I'm going to take you through just like this step here, where we go from have some data that's already been collected, and we're just going to send it over here, and then you'll see it all work here. So the first thing that we would do is, if you're a new user, is you would come over to the mail-in site and you'd say, hey, I want to book a slot. And I put in a dummy one here, or a dummy shift here just for today. And I'm just going to say, I'm going to put a tag in here for BioSACS workshop demo. And I'm going to go ahead and book a slot. And it's for SEC SACS. So for SEC SACS, you would, you would fill in the buffer that you're going to use. I'm just going to, for time, I'm just going to 10 millimolar, or I'll just use this one, right? You choose a column, right? Confirm your selection, right? And then you can have, I think, up to 6 or 7, 8 or 8 samples. It's in the instructions, I think, down here, but we'll go ahead and add something. So again, I'll just say it's RAD 51. The sample volume's like 20 microliters. The concentration is 45 mg per mil. Molecular weight is huge, or I can't remember what huge is because it's been a while. And then I have to give it my simple scattering login. right? And I'm going to add another one. We'll add XPG and say 15 and 22, and we'll make it smaller, right? And this should just fill in by itself, right? So then I filled in 2 samples, right? And so from that point, that stuff is all recorded. And so as an admin over here, I would come over to the tracker here. Tracker, there you go. And then we see that, oh, we have 2 samples for SEC Sax from David Shin. So what happens there is we download, this is what happens for the people that are running the Beamline. They will download a spreadsheet. I'm going to go ahead and replace it. And then here we will reopen it. Let's see. Right. Come on, baby. Well, try that again. Oh. Right. So now it has all the information for the different, all the information from the different, all the collections. So I only put in 2. It has 4 because I did 2 of them last night. And from there, they go ahead and collect the data. And then after that, we just go ahead and we fire it off automatically. So this is kind of like this is our staging program is where I'm going to send it. So you see that there hasn't been anything uploaded in a while. And so it's not going to be the same data set because just for brevity, I'm just going to do a really quick one. So I'm going to send, but we're pretending we're sending all that stuff. We're actually uploading some other like demo files at the moment. So basically they just have to click a couple buttons on their GUI on their end, and then it'll go ahead and upload. So a little slow because we had to like wake the system up, right? So the information that you end up getting is at least on our end is like what data set from the mail-in site is there with the URL for it, and also where it goes to the Simple Sax site. So now as a user over here, if I reload this, whoops, not my data sets, but all the data sets, because this is for somebody else. We're pretending it's from you. So so this is the one that we just uploaded. And then from there, you would actually receive an email, and you can go back to your in order for you to go back to the mail-in site and match the 2 up. And then again, if you want to publish it, then all you have to do is come over here, click edit, fill out the rest of the data, and then click publish. So I think Greg wanted me to keep this one a little shorter, so I think we're basically about done. And I just want to like talk about some things that we're planning on adding, which is APIs for data download. And that'll be important for our integration with research computing. And of course, adding DOIs for the data sets. Some recent requests were to link related data sets together. Another request was the ability to share data sets with other users prior to publishing. And then again, we're going to be tying this in with research computing to like start pumping in even more data, and maybe also to fetch it out. We're going to start using spreadsheets for uploads to improve the metadata that comes along with it. And then one of the journal editors suggested a way to access data anonymously. And Greg wants me to integrate some Sax frame slice and Sax similarity. So I've actually been kind of working on that through my new Flask backend for that. And then also we're going to be upgrading it to Ruby on Rails 7, currently 6, to add images. Right. So that's basically about it. So for acknowledgements, I have The usual suspects of the ALS SIBYLS beamline. It was kind of like Greg's idea to start off. Scott runs parts of the AWS cloud system and helped write part of the GUI with Daniel Rosenberg, who was a graduate student here. I often talk to Kevin and Yvonne. They were here before, and Kevin was the one that wrote the original mail-in site. Catherine, of course, runs everything. James Holton always has good input. Jane Tanamachi, Chris Brosey, who doesn't actually technically work at ALS or SIBYLS, but she was kind of related to the lab, gave me a lot of good feedback, and she puts together some pretty decent data sets up there. Dan and Mikkel, LJ, Susan also always giving us great suggestions and everything. And the one thing I never did before was actually acknowledge the people that I really got a lot of help from also. I'm not going to rattle them all off, but people that helped me with software development, data structures, algorithms, understanding hardware, and stuff like that, and especially like web development and relational databases, stuff like that. So especially for, I guess, for this particular one, quite a bit of help from the top two, Josh and Dave Doolin. So, okay, with that, any questions, comments, or concerns?